What is up, pre-algebra students? This is lesson 68. Our objective is, what is and how do you use the multiplication rule of probability? And we will talk about what that is, but let's first do a little bit of discovery here with the first two examples. So example 1 says, how many possible outcomes are there for an experiment in which two number cubes are rolled together? So think about, you have two dice, they have 6 sides on them, and you roll the dice. They're wondering how many possible outcomes, how many possible answers could there be if you were to do that? Well, let's just look at the first cube. It could either be a 1, a 2, a 3, a 4, a 5, or a 6, because there's 6 sides on it. And the second number cube could either be a 1, a 2, a 3, a 4, a 5, or 6. So now we can kind of fill in this table here. If we got, this would be like 1, 1. This would be 1, so this would be 2, 1. This would be 3, 1, 4, 1, 5, 1, 6, 1. Next option would be 1, 2, 2, 2, etc., etc. You can see how this is going. Alright, so you can notice there I filled in the rest of that. I didn't make you watch me to fill that in. Alright, so notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 36. So the answer to this is 36 possible outcomes. Okay, and there's what we call the fundamental counting principle, which means that if there's 6 options to the first one and 6 options to the second one, you can just multiply those. Because notice 6 times 6 is equal to that 36. So we could have just multiplied 6 times 6 and gotten the answer. Here's example 2. Two number cubes are rolled once. How many possible outcomes are there for which the first roll is even and the second roll is even? So notice, this is the same table as the one I just filled in, except for it looks a little bit nicer. And so, but they're wondering, how many possible outcomes are there if the first and the second are even? So notice here, we have 3 options here, where one of them's even, and over here, where this is even. So if we're looking for ones that are both even, right? So notice we have 3 options of the first one and 3 options of the second one. So we think our answer is going to be 9, but let's just check that. Notice this one here is both even. This one here is both even, both even, both even, both even, both even, etc., etc., etc. If you go through, because it says, where is it? For which the first roll is even and the second roll is even. So notice, first roll is even, second roll is even. If you go through and look at all the rest of these, either the first one is not even, the second one, like here, the first one is not even. Here, the second one's not even, right? Here, the second one's not even. Or they're both not even, like here. So the answer is indeed 9. Okay, now this is where we get to the multiplication rule of probability. And it says if event A and B are independent, this is the key word, then the probability of A and B is equal to the probability of A times the probability of B. That's a lot of words and funky symbols. So let's just talk real quick about independent events. Independent events are events that don't affect each other. Like for instance, rolling a dice, or rolling 2 dice like we've just been talking about, whatever the answer of one is does not affect the answer of the other one. Right? If you roll a 1 on the first one, there's no way going to guarantee that the second one's going to be a 1 or prevent the second one from being a 1. So those are what we call independent events. Same thing with flipping a coin, right? Those are independent events. If you flip a coin twice, the outcome of the first one does not affect the outcome of the second one. However, let's say if I were drawing cards from a deck, if I wanted to draw 2 aces, if I drew the ace the first time, because the first time I look at the deck there's 4 aces, if I drew one out the first time, then the second time there's only 3 aces. And so those would be what we call dependent events. And that has a little bit different way of calculating that. So independent events, you can just multiply the probability of the first one times the probability of the second one. Let's try that out. Suppose a bag contains 2 red and 3 blue marbles. Robert selects a marble from the bag, looks at it, then replaces it. Then he selects a second marble from the bag. What is the probability he selects a red marble and then a blue marble? So first of all, there are 2 red and 3 blue for a total of 5. So notice these ones are what we call independent events because he puts it back in there. If he had kept the marble out, then those would be dependent events. But since he put it back in there, then there's 5 the whole time. So we're wondering, what's the probability he selects a red, then a blue? So let's see, the probability of a red, well, there's 2 red ones and there's 5 in all. And the probability that he selects a blue one, well, there's 3 in the bag and there's 5 in all. So the probability of him selecting a red one and then a blue one is going to be 2 times 3, which is 6, over 5 times 5, which is 25. And normally we're going to want that as a percent. I'm just thinking here, if I can get this bottom to be a 100, that'd be an easy way to do that. So that would be 24 over 100. So it'd be 24%. So you say 24%, or you could say 6 over 25. Or if this wasn't so easy to multiply it by 4 and get to 100, you just divide this, right? Like 6 divided by 25, and work that out, and you would get 0.24 in this case. So you could leave it as a decimal. So any one of those would be fine, but probably we'll go with that 24% is the answer we're wanting. Alright, Maribel holds a stack of 52 alphabet cards, 26 uppercase cards with A, B, C all the way to Z, and 26 lowercase cards, A, B, C, etc. all the way to Z. She shuffles the stack and selects one card. What is the probability that it is an uppercase vowel? So notice it says uppercase vowel, which means it cannot be lowercase, it must be uppercase. And vowels are just A, E, I, O, and U. We're going to leave out Y, because these are for sure vowels all the time. So notice there are only 5 uppercase vowels. So there are 5 good outcomes, favorable outcomes, what we call that. And there are 52 alphabet cards in all. So that's 5 out of 52. If you put that in a calculator, or work that out by hand, you get 0.09615, and it keeps going from there. So we'll say this is about 10%. About 10%. Alright, your homework for today is on page 460. You're going to do the practice set, and then 11 more of your choice. Good luck.